Hi, we're a group of students from National Taiwan University, and we're now going to discuss the facts about traffic accidents in Taipei. And we'll now see the contents. I'll show you why, what, and how we did it. In Taiwan, some people regarded elders, women, and old women as traffic disturbance. In order to find out the fact about traffic disturbance, we used the open data of 105-year Taipei traffic accidents. We considered the variables of genders, ages, and injuries in our model and discussed which variables could cause the traffic accidents through Bayesian statistics. Then we moved on to have Joy to introduce data preprocess.
Hi, I'm Joy. Talking about data preprocessing, there are two reasons that lead to data preprocessing. First is lack of information, and second is exacting unreasonable numbers. And there are two steps to process the data. The first is clean rows including non-data and unreasonable data. And second is set dummy variables for some columns. And talking about the variables, in gender we have two categories, man and woman. And in age, we just standardize the raw data. And about the wounded, we have 5 degrees of injury. Okay, let's move to Ramio's part.
Okay, hi, I'm Romeo, and I'm going to introduce the exploratory data analysis part. In this part, we will have 3 variables visualized as pictures, and the variables are age, gender, and degree of wounded. So now this picture is about age. The x-axis is age and the y-axis is accidents happened. As you can see from this picture, people whose ages are around 20 to 25 have most accidents counts. So now is the second picture. It's about gender. The x-axis is gender, and the 1 means male and 2 means female. The y-axis is accidents happened. So we can find out that men accounts for 74% of accidents counts. So now let's move to the last one. The last one is about the degree of wounded. The x-axis is the degree of wounded. And the 0 means unclear, 1 means not wounded, 2 means wounded, 3 means died in 2 to 30 days, 4 means died in 24 hours. And the y-axis is accidents happened. So you can see the degree 2, which is injury but did not die, accounts for 57%, and degree 1, which is not wounded, accounts for 40%. Now let's Kyle introduce me.
Hi, my name is Kyle, and now I would like to share how we build our model and what is the result. So we would like to know how age and gender affect wounded ratios. Now we run 2 simple regression and run 2 multiple regression. First, we run age, and then we have gender, and a combination of 2 parameters. And finally, we add the interaction terms to the models. And on the right-hand side, you can see that the upper table shows that M2.1.1 have the highest weighted ratio, which is 1. And this means that the first model, age, gender, and the interaction terms, is the best model for us to make prediction. And we will use this model for our further analysis. On the below tables, we can see that the parameters shows that both three of the parameters are all negatives, which means that the higher the age will be, the lower the wounded ratio will be. And being a male will lower your wounded ratio too. Also, for those who are older male, they have overall lower wounded ratio as a plus. And we are very interested with the interaction terms, and we want to know whether it is effective or not. So now we go for another analysis. Now we build another chart to see if the interaction term really matter or not. So we can see the blue curve will be the male, and female will be the black curve. And the difference of these 2 curves is the red curve. And we can see that the gamma did not across 0, so which means that the interaction terms did matter. The older male have overall lower wounding ratio. And this is interesting, so we want to know how the effects change across the gender or across the age. So we will go further in our counterfactual analysis. Now, in this chart, we can see that we want to focus on male, to see whether the male effect have changed across age. So in the right-hand side, we can see that it seems that the older the male, the lower the wounding ratio would be. So this could tell us that maybe it was because young guy could drive faster, and because lack of experiments, they easily get higher wounding ratio. And for the male, older male, they are experienced, so they have lower wounding ratio, which is consistent with our intuition. On the other hand, for the female in different age, we can see that it seems that the age effect does not really change and does not influence across the age and in the female. So it means that the experiments or any other accumulation of knowledge does not help female to avoid the wounding ratio to make it lower. And this is the basic difference between gender, between male and female. And we would like to further know whether gender has different influence across age. So here we built another chart. We can see that those who below median age will be the black dot, and those who is above median age will be blue dot, and the dot will be separate as female and male. And we can see for the black line, is for the youngster, it seems that gender does not matter to the wounding ratios, which means that for young guys, they generally get same wounding ratio, no matter whether you are male or female. On the other hand, for the older male generally get lower wounding ratios, which means that if you are older people, being a male can help you get lower wounding ratio because you are more experienced in driving or traffic. So this is the result what we have found in gender and in age. And we further make prediction. So the blue line will be male and the female will be the red line in this chart. We can see that although when the age is for the youngster, the male has a slightly higher wounding ratio, but after a certain age, they will have lower wounding ratio compared to women. And you can also notice that the shady area does not change or does not twist it because we only use one models. So the shady area is exactly the same as the line. And this is our result. Now, we would like to further do an MCMC curve, MCMC analyze to see if our result is consistent and stable. And you can see that on the right hand side, the chain does not fluctuate a lot and has also become stable after 1000 trials. And also for the below tables, you can see that the effect is also negative in the 3 parameters, which is consistent with the Gaussian models. So this tells us that our result and analysis are consistent and stable. And this is our result.